first ones we're going to do are the basic ones. We already really talked about this in 8.1. Okay, all you do on this, these are lines. So if you have theta equals some number, then you know that's a line. Okay, so the graph of this would be go to pi over 2 and draw the line. Okay, the line goes in both directions like that. That's a vertical line. So that's how you would graph that in polar. Okay, this next one is really negative 60 degrees. So again, what you would do is locate where negative 60 is. That's the same as 300 degrees like that. And then again, what you do, real simple, is you just connect that into a line, just identify that angle, and that's how you graph that. So one of the cool things about polar, sometimes the equations are easier. You know, sometimes they're not, it kind of depends, but that's how lines go, is like that, okay? The next thing, I'll kind of get through the simple ones here first, is a circle with a center of 0, 0. So we kind of looked at this in the last section when we did conversions. If I have r equals 5 and I want you to graph that, all you do is just go to the 5th circle and you highlight it. That's it. So see, that again, polar is simpler in a lot of ways. That's the graph of r equals 5, okay? The graph of r equals negative 6.5, it doesn't matter that radius is negative. That still doesn't matter because all the points are still going to be 6.5 out. So what you do on this is just go 1, 2, 3, 4, 5, 6.5. So it would kind of be halfway. God, it's hard to draw a circle on this. So you get the picture, okay? All right? So that's it. I mean, it's super easy to graph circles and lines, and polar is nothing to that, okay? Just want to know the structure of that and what those things mean, okay? All right, so that should be real simple for everybody. Okay, now I'm going to show you how to graph in polar. So get your calculator out. And polar graphs are kind of interesting. So I'm going to, I kind of tried to write down everything you do to get your graphing calculator set up to do polar. The first thing that you want to do is make sure that you're in radian mode. I'm going to set up, you can do degree mode, but you got to be consistent with your window. So we're going to go radian mode and make sure you're there. Then the next thing we want to do is mode polar. So if you go to your mode button, if you go down to this here, you're going to learn about parametric in calculus 2. You want to just go to polar. So get it blinking on polar, then press enter, and now you're ready to do polar coordinate graphs, okay, like this. Well, okay, we're going to set up a window. I'm going to have you set up this window that's on the handout. So if you go to your window, it's totally different now. You're going to have theta minimum, that's like 0 radians. Then you want to go 2 pi. You can make this anything you want to. You can make it go more than one lap around the circle. So I just go 2 pi. I would generally use a small number here, like 0.1 or even smaller, sometimes better. Let's go 0.05. That's even better. But don't go too small. If you go too small, your polar graphs will take an eternity to graph. If you make it too big, they won't look right. So 0.05 is kind of a good standard. 0.1 is okay also. And then the x's, this is just like an xy axis. So I think the polar graphs that we've been working on, we're going -8 to the left, 8 to the right, and then do the same thing with y. Down 8, up 8, scale like that. So just get that set up. That's on your handout. You can use the 0.1 if you want to for theta step. And theta step just tells you how big the angles are going to, like that. Okay, well, let's graph one thing, all right? So now what you do is press your y equals button. If you press your y equals button, now it's going to say r equals. So let's do a circle. Let's just put in something like, whatever, like r equals 6. So if you put in r equals 6, press graph, you got a circle. Now, it doesn't look like a circle. It looks like an oval. The reason it does that is because the x-axis is stretched out. So you can do this. This is a good thing to learn how to do. If you go zoom square, option 5, then it makes it look the way it's supposed to. So the standard default on these calculators is to have the x-axis stretched out a little wider. So zoom square is the way it really looks. That's it, okay? And you can do all kinds of stuff on this. You could make yourself a dartboard if you wanted to. You can go through and do all kinds of stuff on this. Polar graphs can be really interesting in general. So you want to get everything set up, your window set up, and then your graphs, your equations always have to be solved for R. Okay? Everybody okay with your calculators? Any question on that? You got something? Are you not getting yours right? Let me take a look real quick. Are you in radian mode? Oh, you got that inspired, so you're in radian. You're in polar. Now, where do you put it? Where do you put your R equals? And to do a little Googling on that. I just have never used the Inspire. Okay, so let's, a lot of these things like this, like the formulas for the equation of the circle, you don't really have to know these things right here. I'm just giving those for reference. When the rest of the graphs we're going to do, we're mostly going to do a table of values on some of these things and use our calculator. So we're going to go ahead and fill this table out on this one, and then we're going to plot it in polar. Now, the further you increment the table of values, the more accurate it becomes. But this one, I just want to fill this out then. So again, this is all unit circle. You're doing a cosine of theta. So I'm just going to highlight the x values around the unit circle, and you can do all this in your head if you want to. So the first point is going to be r equals 5 cosine of 0. Cosine of 0 is 1. So 5 times 1 would be 5. Okay, like that. And we're going to plot these points kind of as we get those then. So you have a point 0, 5. So on polar, you go to 0, then you go out 1, 2, 3, 4, 5 towards it. That's where your first point is. A lot of times I like to just number the points because we kind of connect the dots in that same order. Okay, I go to the next one. I'm going to have r equals 5 cosine pi over 2. Cosine of pi over 2 is 0, so that'll give you 0. Okay, so if the radius is 0, that means you go back to the center. So that second point goes in like that then. Okay, and then we'll crunch out a couple of more. To go to the next one, we would have r equals 5 cosine pi. That would be 5 times negative 1. So that would be negative 5 like that. And then again, what this one means is you go to pi, but since the radius is negative, you don't go this way, you go backwards this way. So you're actually back at this point right here. So that would be the third point you go to, like that. Okay, then when you start getting here, these things start repeating. So if you crunched out 5 cosine 3 pi over 2, that's 5 times 0, so that's 0. So then you're back to the center again. So your fourth point would go like that. So it's kind of alternating back and forth between those 2 points. And then this last one, you would have 5 cosine 2 pi. Cosine of 2 pi is 1. So 5 times 1 is 5. So now you're back here again. Now, you really on a table would probably want to get more points than just go by pi over 2, because it's a little bit ambiguous what's happening. What's happening is this is a circle that's that has a center halfway in the middle like this. So the center of that circle, the center is 2.50. If you have a cosine, the center of the circle ends up being on the x-axis. So I just kind of put a little dot there, and then all I want you to do is just draw a circle around this. And then we'll check this on the calculator, okay? So what we're looking at right now is we're looking at circles that are on an axis. Their center is on an axis, okay, like that, right? So if you put this one in your calculator, it would go like this. You would go 5 cosine theta, whoop, and you put that in, that's what it looks like, okay? So you're going to do most of your graphs you're going to do on your calculator, but just get the idea of how the table of values works on enough of these things. Another thing that's kind of good to do when you're learning polar graphs is trace. So like if I trace at 0 and then press my right cursor key, then you can see that thing moving around the circle. That's the order that those points get plotted in is kind of like that. So it's going around the circle basically counterclockwise like that, right? So that's how that one would go. Anytime you have a number times cosine theta, that's a circle with the center being halfway in the middle of that number there. So it's 2.5. If that was -5, that would be -2.5, like that. Okay, all right, the next one goes like this. Okay, so I'm just going to fill out the table of values on this, and I'm not going to crunch all this out. -3 times sine 0 is 0. If you do sine of pi over 2, that's 1, so that would be -3. Sine of pi is 0, so that would be 0. Sine of 3 pi over 2 is -1. That would be +3. And then sine of 2 pi would be 0. All I'm doing is just -3 times the sine. I just kind of did that in my head. Now, if you plot the points on this, it goes like this. So your first point is anytime the radius is 0, you're in the center. Okay, like that. So that's point 1. The second point, you go to pi over 2, has a negative radius. So that means you go down 3. So that's your second point. The third point is pi 0, so you're back to the center again. That's point 3. And then the next one, you go to 3 pi over 2 down here. Then you go out 3, so you would be there again. It's going to be a circle drawing around these points like this. So the graph is going to roughly look kind of like that then, okay? The center of this circle is going to be 0, -1.5. The center of the circle is there. Now, if you put that in your graphing calculator, that's what's going to come out on that thing then, okay? So again, what I want you to do is just kind of get an idea of how some of these graphs go. Okay, you guys understand what I'm doing okay up here? Okay, mostly the points I'm getting from the unit circle, so that's not radically new to you. And then, of course, you've got to know how to plot polar coordinates, okay? And then most of these graphs are just want you to get familiar with your calculator and how to do some of these in polar. So these right here, you want to know the cardioid. What we call a cardioid always looks like this. It's R equals A plus or minus B cosine theta, or you can have a sine theta. And the thing is, A and B turn out to be the same number. Now, they can be off by a negative or something. So 3, 3, 4, -4, that's what makes it a cardioid. Cardioids graphs look like a heart. Okay, like for instance, when I record music, okay, I use a cardioid microphone. Okay, if you're a musician and you know anything about microphones, there's a pickup pattern called a cardioid that allows you to go directly into the microphone. It picks up things like from your amplifier versus omnidirectional, which picks up a choir. So cardioid microphone, like my microphone I record with, has that little symbol on it, that little cardioid thing, okay? So it goes like this. What we're going to do is just fill out this table of values on a couple of these things and get this put together here. Let's see, batteries. I must not ever plug this thing in or something. All right, so we're just going to go to the unit circle, and let's just crunch this first one out here. So what we're doing is R equals 3 plus 3 cosine of 0. Cosine of 0 is 1. So 3 plus 3 is going to be 6. So that would be your first point that you have. Then I'll go to pi over 2. I have R equals 3 plus 3 cosine pi over 2. Cosine of pi over 2 is 0. So that would end up giving 3 plus 0 would be 3, like that. And I'm just going to crunch out the rest of them the same way. This is the kind of thing that you're going to do on your final, okay? A polar graph, fill in a table of value, plot, okay? And then the numbers are going to go to the unit circle, okay? So you'd go like this. R equals 3 plus 3 cosine pi. Cosine of pi is -1, so you get 3 plus 3 times -1, so that gives 0. And then the next one will go R equals 3 plus 3 cosine 3 pi over 2. Cosine of 3 pi over 2 is 0. So that'd be 3 plus 0, that would be 3. And then these are the same. I mean, since 0 and 2 pi are coterminal, they're going to give you the same answer back again, like that. So what we're going to do is that stuff just comes directly from the unit circle, looking up the cosine. Now we're just going to plot the points. I always recommend that you kind of put the order that they're in. So the first one is theta is 0. You go out to the 6th radius, 1, 2, 3, 4, 5, 6. So that's point number 1. Point number 2, you go to pi over 2, and then you go up 3, like that. So that's your second point. Then you go to pi 0, so out to pi. Anytime the radius is 0, you're dead center like that. So that's the third point. And then the next one is 3 pi over 2, 3. So you go towards that. That'd be your fourth point. And then we go 2 pi over 6 back to 6 like that. Okay, now in order to know how the rest of these points go, you have to know it's a cardioid. Okay, so it goes like this, and it doesn't have to be perfectly drawn, but it goes kind of like this. You start at point 1, you go to point 2, then you go to point 3, you kind of dimple in. It's going to look like a heart. Then you kind of come out and then go kind of like that. Okay, that's how that graph looks. Let's put this in the calculator so I can show you what these things look like then. So you would just put in 3 plus 3 cosine theta, and it should be roughly the same thing we just did, okay? Looks like a beam, kind of, okay? Right? That's what cardioids look like, so you'd have to kind of know how to do that. Now, you could break this up, like if you broke this up into 45 degrees instead of 90, you would get a little bit more accuracy with your points, but that's the idea, is get the idea of what the cardioid structure looks like, and then be able to put that together. Okay, let's do the next one just totally on the calculator. Right, so this is also a cardioid, and what's going to happen, what I know, is if there's a cosine, the dimple is on the x-axis, so it kind of dimples in towards the x-axis. If it's a sine, then the cardioid either does that or it goes like that, so it's kind of like up or down, kind of like that. Okay, so let's just put this in the calculator, and I'll show you how to trace out values on this also. So we go 4 minus 4 sine theta, and then just graph it. Okay, this is going to be, I think, the heart will be kind of be like a Valentine. Look at that, isn't that cool, right? So what would happen on this then, you can trace like this. You can trace at 0, and we can fill out the table this way, so we just get 0 there. If we go to pi over 2, you can trace at pi over 2. And then that gives... that makes sense. Did I trace the first one right? No, x is 4. You got to read it like this. I didn't read that right. So the idea is you look at the x and y values. So right there, that's out 4. Kind of goes like that. Look at those numbers down there. Then if you trace at pi over 2, then you're at the point 0, 0. Okay, so the radius is 0. Okay, if you trace at pi, then you're at -4. See, that says you're at the point in rectangular -4, 0. So that's -4. And then if you trace at 3 pi over 2, that'll be down below the x-axis. See, that's the point 0, -8. Okay, so you end up on that one kind of getting that the radius actually would be 8 on that then. Okay, like that. Okay, and then 2 pi, you would be back to the beginning, you would be at 4 like that. Okay, so then if you plot these points out, you would have the first point would be 0, 4. So you go like that. Second point, pi over 2, 0. Third point, pi, and that would actually be pi 4. I mean, that would go towards that. So this would be pi 4. Like that, and then the next point would be 3 pi over 2, 8, and like this. So basically it would go like this, and then you can just kind of connect the shape kind of like that. Okay, and that's the idea. So those are cardioids. That's how the graph of a cardioid looks like. We're going to look at a few more of these next Wednesday.